Welcome to Rocket Science for Everyone. Are you ready? Let's do this. In this course, we will largely focus on satellites that are in orbit around the Earth. And in this segment, we will ask, what is an orbit? What does it mean to be in orbit around the Earth? To answer this, I will start with an easy question. What happens if I am holding a ball and I drop it? This isn't a trick question, right? It falls. And if I ask you, why did it fall, you are very likely to say, gravity. The gravity of the Earth is pulling the ball down. Well, that's cool. So now what happens if I toss the same ball gently in some direction? So again, the ball will fall, but this time it will also move with some distance, some horizontal direction. If I toss the ball harder with more horizontal speed, the ball will still fall, but this time it moves much farther away from me. So now imagine that I'm a professional baseball player and I throw the ball incredibly fast. And let's get rid of the atmosphere while we're at it. In the absence of gravity, the ball would continue in a straight line. But we know that gravity is pulling the ball towards it. So this super fast ball still falls. Gravity is still pulling the ball towards it. But now it's going so far in the horizontal direction that the Earth is curving underneath. And there must be some speed, some horizontal speed, where the ball keeps falling, gravity keeps pulling, but because the Earth is curved, the ball keeps missing the surface. At this special speed, the ball continues all the way around the Earth and will boot me in the back of the head. This, my friends, is a definition of an orbit. If an object is falling towards the Earth, but has enough horizontal speed to keep missing the surface, the object is said to be in an orbit around the Earth. If the horizontal speed is perfectly balanced, the object will travel around the Earth in a circle, a circular orbit. The speed to achieve orbit is crazy fast. Near the Earth, in what we'll call low Earth orbit, it's more than 7 kilometers a second or 17,000 miles per hour. Compare that to the fastest baseball pitch ever, which is only 100 miles an hour. If I throw the ball even faster than what's needed for a circular orbit, the ball will move further from the Earth, but gravity still wins and the ball will be pulled back towards the Earth. And this is an elliptical orbit. There's some speed where the ball will win its fight. It'll break out of the icy grasp of Earth's gravity, and that speed is called the escape velocity. The escape velocity is the velocity we need if we want to head out beyond the Earth and the Moon into interplanetary space. So, coming back where we started, the difference between the ball that I dropped and a satellite in orbit is the horizontal speed. That is, a satellite in orbit around the Earth is just falling like the ball. It's moving fast enough that it keeps missing the Earth. And that's kind of weird to think about, right? Like, consider the astronauts on, say, the International Space Station. We think of astronauts as being weightless, as like floating out there. But astronauts in orbit around the Earth are actually just falling. It appears to be peaceful and floaty because everything around them is falling too. And this is a really different way to think about weightlessness. And there's definitely some confusion because another word people use for weightlessness is zero gravity or zero G. Neither of these are particularly great terms. For the astronauts on the space station, the Earth's gravity is still pretty strong, but because they are falling, it appears that there is no gravity. So a better way to describe weightlessness that astronauts feel in orbit is that they are in free fall. Okay, so let's summarize what we just covered. Suppose I have a cannon on Earth. If I shoot a cannonball too slow, it'll fall back to Earth after moving some distance. If I shoot the cannonball with more speed, it can go all the way around the Earth and make a circular orbit. More horizontal speed will result in elliptical orbit, and even more horizontal speed still, an object can break free of Earth's pull and continue out into interplanetary space, the escape velocity. And at this point, you might say, Professor, you've got a cannon pointed horizontally, and the last time I checked, rockets are launched upwards, not horizontally. And I agree. Rockets are definitely launched upwards at first. Rockets need to go up so they don't hit things like houses or mountains. They also want to get up above the thick part of the atmosphere, which slows things down. But if you wait a minute or two after a rocket launch, the rockets going into orbit will turn over and most of their speed goes into horizontal motion, not vertical. And after a few minutes after that, the rocket engine turns off. Satellites will then be in orbit, continuously falling around the Earth while Earth's gravity pulls it back. In the next few segments, we'll talk about different kinds of orbits around the Earth. But to end this segment, I wanted to note the difference between being in orbit and being in space. Being in orbit is a special thing. For example, anytime a spacecraft is moving with its engine on, it is no longer falling freely and therefore it is not in orbit. Or if you're traveling out in deep space, you're not orbiting anything. So it's possible to be in space, but not in orbit. That said, most of what we'll focus on in this course will be satellites in orbit around Earth. So now we've talked about what we mean by an orbit. In the next segment, we will define where above our head space begins.